Good day, everyone. I am your teacher Anton. This is the continuation of the discussion of the polynomial functions and their graphs. Now let's proceed from the end behavior of graphs of polynomial function. This is the end of behavior of the graph of polynomial function. The end behavior of the graph of polynomial function is determined by its leading terms. The leading terms is located from the first term or the highest degree of the equation. For example, p sub x equals x raised to 4 minus 3x raised to 3 plus 2x plus 1. The leading terms is located from the highest degree, which is 4. X raised to 4, this is the leading terms. And it is a positive. This means that the graph of the polynomial resembles the graph of p sub x equals ax raised to n, where ex raised to n is the leading terms. The following notations are used to describe this behavior. X arrow plus infinite means x becomes larger and approaches positive infinity. X arrow negative infinite means x becomes smaller and approaches negative infinity, since negative infinity. Now the table is this one. We need to follow the table on how to determine the coefficient. P sub x is odd degree. If the degree is odd and it is a positive, this is the form of the end of the behavior of the graph. And if it is negative leading term and odd degree, the form is this one. X positive infinite, px negative infinite, and as x negative infinite, p sub x positive infinite. And the form is start from the lower and lower. How about if the leading terms, how about is the highest degree is even numbers or degree, and if it is positive term, it is upward. And it's the form of the end of the behavior of the graph. And if it is the leading term is negative and the exponent is even degree, the form of the end of behavior of the graph is this one. Now let's start. The questions here is there is a table. Fill in the tables. So now we need to determine the degree, the leading coefficient, the turning points, the end of behavior of the graph. I already discussed the degree, the leading coefficient, and the turning points, and now the end of behavior of the graph. And this is the given equation. The given equation is already arranged from the highest degree to the lowest degree. And the highest degree is 7, so the degree is 7. And 7 is odd numbers. We need to put odd numbers. And 7 is the highest degree. How about the leading coefficient? What is the leading coefficient? The leading coefficient is 3. And it is negative 3. So write negative 3. And it is negative. Always the highest degree is located from the first term, and the leading coefficient or the leading terms is located in the first term. You need to arrange the equation in descending order from the highest to the lowest so you can determine the degree and the leading coefficient, then the turning points. As I said, in the turning points, you can determine the turning points from the highest degree. The highest degree is 7. You can write as less than. You can estimate as less than 7. When you say less than 7, it means the turning points is not 7. I write less than 7, it means the estimated of the turning points can be 6, 5. And how about the end of behavior of the graph? So I show you already the table on how to answer the end of behavior of the graph. Since from the table here, from the highest degree is 7 and it is odd numbers, P sub x is odd degree. It is an odd? Yes. It is an odd numbers. Since it is an odd number, so from the table, you can follow the odd numbers from the column odd numbers. From the column positive and the column negative. So what is the leading coefficient of the given? Negative. Since it is negative, so look for the column negative. So add degree, which is 7. And since it is negative, the leading coefficient here is negative. So you can copy this column. And this is your end of behavior of the graph. So copy this one and also this one. X arrow plus infinite, comma, P sub x arrow negative infinite, and as x arrow negative infinite, P sub x plus negative infinite, and the form of the graph, possible form of the graph is lower and lower. That is how to fill in the table. Now the last question is find the real zeros of the following. By finding the real zero of the following, you can factor the given, or you can use the synthetic division to find the real zero. The factor of G sub x is equals to x raised to 4 plus x raised to 3 minus 3x squared. What is the factor? You can use factoring by x minus 1, 2x plus 3, or x raised to 2. If you can multiply first this, and then after the result of this, then multiply the last multiple, the result will be 2x raised to 4 plus x raised to 3 minus 3x raised to 2. You can check that one. Then after determining the factor, then equate to 0. All the inside the parentheses, you need to equate into 0. So x minus 1 equal to 0. 2x plus 3 equals to 0. And x raised to 2 is equals to 0. Then continue. Then you need to find the real zero? By transpose the number of negative 1. X equals positive 1. Why is this positive? From the equations given is negative. All numbers na ilalabas mo sa equal, it will change the sign, becomes 1. And 2x equals negative 3. How to find the value of x? By divided both sides by 2. Then x value is negative 3 over 2. How about the next? X, there is no constant, so equals 0. There is power, so square root, then square root. Cancel. X is equals to square root of 0 is 0. And the real zeros are 1, negative 3 halves, and 0. This is your final answer. You can use factoring if you know how to factor the equation, and if you can't factor, then you can use synthetic division. Always remember, when you find the real zeros using synthetic division, always to guess the divisor until the remainder is become 0. If the remainder is not 0, the divisor that you choose is not a real zero. It becomes a real zero in synthetic division if the remainder is 0. That's it. Now, thank you and God bless, and always support my video. Don't forget to subscribe and share so you can follow my next video. Thank you and God bless to us.